Trigo.
Hi there, Loreto baby! This is October 11th. We're now here going to National Bookstore to buy some illustration board.
Transition time, everybody do what you need to do.
I'm Sacman.
I'm RJ Halili. I'm Justin Day, Gumba. I'm Angelo Bringula.
Medrano.
And we're both night.
So we're filming. Yeah.
We're vlogging.
We're vlogging, rather.
We're vlogging about the trigonometry. By money.
Transition time, everybody do what you need to do.
So hi guys, we're here at Gumba's house. So we're going to talk about the trigonometric identities. So first one, what is the meaning of identity? Identity is the equation which is true from any value of its variables. If you replace x with any number, the equation will still be correct. So for example, So hi guys, I'm back and I'm here to present to you my example of identity equation. This is my equation. The equation is 5 times the quantity of x plus 2 is equal to 5x plus 10. So we're going to use a distributive property where 5 times x is equal to 5x and 5 times 2 is equals to 10. So 5x plus 10 is equal to 5x plus 10. So therefore, it is identity equation. So the second one is the conditional equation. Is an equation which is satisfied only by some values. So it means that only some values will make the equation correct. So here's the example. Be right back. So hi guys, I'm here to explain to you my next example for conditional equation. Okay, I will just adjust the camera. Yeah. So my example is 2x minus 5 is equals to 9. So the next one is you will copy the 2x and you will distribute the negative 5 to the other side, and this equals to 9 plus 5. And next is you will divide both sides by 2. 14 because 9 plus 5 is 14. So you will cancel it and the x will remain. X is equals to 7. Therefore, it is conditional equation. Just practice. So I'm here again to give another example for identity equations. So the first thing you do is you will distribute 2 to the x and 2 to 3. So 2 times x is 2x, 2 times 3 is negative 6, and you will distribute to the negative 2x to negative 6. So it will be positive 2x minus 6. Therefore, it is identity equation. Woo. So hi guys, I'm here to explain now the next equation, which is the contradiction. This is my example. So 12 is equals to negative 36. You can easily determine it if it is contradiction equation if there is no solution. So that's all. Bye!
Hi guys, I am Doreen and I'm going to talk about reciprocal identities. With these boys, they are good boys and Bible studying. And watch out later. Wait for my discussion. As I said earlier, I'm going to talk about reciprocal identities, where a reciprocal of a number is the number that when you multiply by the original number produces 1. For example, the reciprocal of x is 1 over x. Why? Because when you multiply x by 1 over x, you'll get x over x, which is also equals by 1. In this example, 1 over x is the reciprocal of identity x and vice versa. So, in trigonometry, either of the 990-degree angle in a right triangle can be defined by ratios called the sine, cosine, and tangent. By applying the concept of reciprocal identities, mathematicians defined that there are more ratios, and their names are cosecant, secant, and cotangent, where cosecant is the reciprocal of identity sine, and the secant is the reciprocal of identity cosine, and cotangent is the reciprocal of identity tangent. So, here's how the reciprocal identities are defined. The reciprocal of identity sine theta is 1 over cosecant theta, and cosecant theta is 1 over sine theta. The reciprocal of cosine theta is 1 over secant theta, and the reciprocal of secant theta is equals to 1 over cosine theta. Tan theta has a reciprocal of 1 over cotangent theta, and cotangent theta has a reciprocal of 1 over tan theta. Example number 1. The given expression is cosecant theta times sine theta over tan theta times cotangent theta. To get this, we need to reciprocate the cosecant theta by 1 over sine theta multiplied by sine theta over tan theta times reciprocal of cotangent theta, and it is 1 over tan theta. By cancelling sine theta and tan theta, we'll get 1 over 1, and we know that it is also equal to 1. So, for example number 2, we have 2 secant theta times cosine theta times sine theta over 8 cotangent theta times tan theta times cosecant theta. To get this, we need to reciprocate the secant theta to get 1 over cosine theta. So, 2 times 1 over cosine theta times cosine theta times sine theta over 8 times the reciprocal of cotangent theta, 1 over tan theta times tan theta times cosecant theta. To get 2 sine theta over 8 cosecant theta, we cancel the cosine theta here and the tan theta here. So 2 times 1 is 2 times sine theta is 2 sine theta. And 8 times 1 is 8 times cosecant theta, that is 8 cosecant theta. And then 2 sine theta over 8 times the reciprocal of the cosecant theta, that is 1 over sine theta. Two sine theta over 8 times 1 over sine theta. To simplify 8 times 1 over sine theta, we get 8 over sine theta. Since this is a complex fraction, we need to change division by multiplication by reciprocating the denominator 8 over sine theta. So we copied the numerator here, 2 sine theta over 1 multiplied by the reciprocal of 8 over sine theta, and that is sine theta over 8. Since 2 and 8 is divisible by 2, we get 1 and 8 will be 4. The numerator will be sine squared theta, and 1 times 4 is 4. And the answer is sine squared theta over 4.
Hi guys, I'm gonna talk about quotient identities. So there are two quotient identities that can be used in right triangle trigonometry. A quotient identity defines the relation for tangent and cotangent in terms of sine and cosine. So how do we know that tangent theta is equals to sine theta over cosine theta? We're gonna start from sine theta over cosine theta. Since sine theta is equal to y over r, where r is the radius and y is the opposite, we're gonna substitute y over r to sine theta. And since we learned that cosine theta is equals to x over r, where x is the adjacent and r is the radius, we're gonna substitute it to cosine theta. So how? Our expression will look like this. Now, we have a complex fraction. To simplify this complex fraction, we're gonna change division to multiplication and reciprocal the denominator, which is x over r. By cancelling the r's, we'll get y over x, and that is equals to tan theta. So for cotangent theta, just like what we did on tangent, by substituting the value of cosine theta over sine theta, which is x over r over y over r, by copying the numerator and copying the reciprocal of the denominator and changing the this to multiplication, and we'll get x over y, which is equals to cotangent theta. So for example, cosine theta times tan theta, and to simplify this expression, we know that tan theta is also equals to sine theta over cosine theta, and then cancel cosine theta, then we can get sine theta. So another example is sine theta times cotangent theta, and we can replace cotangent theta to cosine theta over sine theta, and we can cancel sine theta so that we can get cosine theta. Another example is 2 cotangent theta times sine theta plus 2 tangent theta times cosine theta. We can change this to cosine theta over sine theta, and the tangent to sine theta over cosine theta. We can cancel the sine theta and the cosine theta, so we can simplify that 2 cosine theta plus 2 sine theta. So for last example, we have here 2 cotangent theta times tangent theta plus 2 cosine theta times cotangent theta over 2 cosine theta. Then we can substitute these two by using the quotient identity, that cosine theta over sine theta, and the tangent is sine theta over cosine theta plus the sine theta, and we can also substitute this by cosine theta over sine theta, and we can cancel these two, sine and sine, cosine, and also this we can cancel sine is 2 sines, then we have 2 cos over 2 cos, and we can cancel both, so we get the answer 1.
What's up guys, it's your boy Justin Lay Gumba, and this is
Ichibo Aaron Halili.
and we will be explaining about the other types of Pythagorean identities. So before we go into that, we will first discuss about the Pythagorean Theorem.
Ta-da! So, yo guys, we all know that from grade 10 or 9?
Grade 9.
Grade 9.
Okay.
We know that the Pythagorean Theorem is a squared plus b squared is equal to c squared. A squared is this, b squared is this side, and the c squared is this side, which is the longest side in a right triangle. This is angle theta, and the opposite of angle theta is the b side, which is, we can call it opposite, and this is the adjacent side of angle theta. So we can replace c by letter h for hypotenuse, b will be changed back to opposite or letter o, and a will not be changed but will have a meaning of adjacent side. So let me clean this up and show you the new equation.
So this is the new formula we've used in the Pythagorean Theorem. The other letters, which used to be a squared plus b squared is equals to c squared, is now replaced to o squared plus a squared is equals to h squared. We will apply this formula into the circle. Okay, so we're back again. We're now applying the new formula to the circle. As you can see, we drew a circle here and we put imaginary lines to form a right triangle inside the circle. We've put the imaginary lines here so we can form a right triangle. This is where the hypotenuse is located. This is where the opposite side of the theta from the central angle is located, and the adjacent side of the theta angle. As you can see, O is parallel to the y-axis and A is parallel to the x-axis. O is equals to y, and A, we're going to replace it later into x. And as you can see, from the center to the arc of the circle, we have a line here. We're going to derive this as the radius of the circle. So since this is the hypotenuse, we're going to replace the hypotenuse into the radius, which is r.
This is the formula before. This is the new formula. So the adjacent is now x because the adjacent side is parallel to the x-axis, and the opposite side of angle theta is parallel to the y-axis. That's why O is replaced by y, and hypotenuse of a right triangle is now the radius because the hypotenuse serves as the radius in the unit circle. This is the formula we have derived. We'll need to equate it to 1. So we divided both sides by r squared for it to be cancelled. So x squared plus y squared all over r squared is also y over r squared plus x over r squared. Since r squared is now cancelled here, it will now become 1. Y over r is simply sine, and x over r is simply cosine. This is the first Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. And let's now derive the second Pythagorean identity.
So we're going to need to derive the second Pythagorean identity. So in order to do that, we're going to start from the first Pythagorean identity, which is sine squared theta plus cosine squared theta is equals to 1. To find the second Pythagorean identity, we're going to need to cancel sine squared theta. So it will look like this. Sine squared theta plus cosine squared theta over sine squared theta is equals to 1 over sine squared theta. So after that, we're going to separate the two terms. It will look like this: sine squared theta over sine squared theta plus cosine squared theta over sine squared theta is equals to 1 over sine squared theta. We're going to cancel the first term since both of them are sine squared theta. It will equals to 1. And we all know that, as discussed earlier from the quotient identity, cosine squared theta over sine squared theta is equals to cotangent squared theta. And from the reciprocal identity, 1 over sine squared theta is equals to cosecant squared theta. And this is our second Pythagorean identity.
We're now going to derive the third Pythagorean identity, and we're gonna start from the first Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. We're gonna divide both sides by cosine squared theta, and we're gonna separate these two terms, and it will be like this: sine squared theta divided by cosine squared theta plus cosine squared theta over cosine squared theta equal to 1 over cosine squared theta. We can see here that the numerator and the denominator is the same, so we can now cancel it, and it will now become 1. And we know that sine squared theta over cosine squared theta is just simply tangent squared theta. Let me write it first. Yeah, there you go. And we also know that the reciprocal of secant theta is 1 over cosecant theta. And since this is squared, we're just gonna copy the exponential power, and it will now be secant squared theta. And now this is the third Pythagorean identities, and we're gonna use these three identities to simplify and solve Pythagorean equations and expressions. And we're gonna be back.
Okay, so we're back again. We here have an example of a given of a simplifying trigonometric expressions. So our given is 2 cotangent squared theta times sine squared theta times secant squared theta all over cosine squared theta.
We know that the quotient identity, the cotangent theta is equal to cosine theta over sine theta. But in here, in this case, we have the exponential power of 2. So we just copy the exponential power of 2, and it will become like this: cosine squared theta over sine squared theta. So now the expression will now become 2 times cosine squared theta over sine squared theta multiplied to sine squared theta times the
Reciprocal
we also change the second squared theta
into its reciprocal identity, which is 1 over cosine squared theta.
We just also copy the exponential power and copy the cosine squared theta. Yeah.
Yeah.
Okay. So
Okay, next is we distributed the sign that used to be here in this term, which is now sine squared theta over cosine squared theta.
this is multiplication. We can see that there's a cosine squared theta in the numerator of the other
Term.
so it will now be cancelled because there's cosine squared theta also here. And as you can see, there's also sine squared theta here in the numerator and the denominator. It can be
Also cancelled. Yeah.
so now the expression will now become 2 over cosine
Sine
squared
squared
theta.
theta.
And we know that it is also the same as 2 times 1 over cosine squared theta. And we know that 1 over cosine squared theta is reciprocal identity of secant squared theta. So now we have from this expression, very long, it is just 2 secant squared theta. And we're now going to solve it by
Giving value of theta.
okay, we're now gonna solve the trigonometric equation that we have got simplified. 2 secant squared theta, we let theta to be 45 degrees. It will now 2 secant squared 45 degrees. We know that secant is r over x.
Take note that we use the unit circle in solving this trigonometric equation. So therefore, our radius is equals to 1.
And x, we know that x is the cosine of a angle. So the cosine of 45 degrees is square root of 2 over 2.
So we rewrite secant 45 degrees into 1 over 2 square root
over 1 over square root
1 over square root of 2 over 2, and we have an exponential power of 2 here, so we copy that into squared there.
Then since this is a complex fraction, we're gonna
Reciprocate the equation.
and change the division into multiplication. So it will now become 1 over 1 since there's an imaginary denominator here. So 1 times 2 is equal to 2, and 1 times square root of 2, because we reciprocated it, right? It will now become 2 over square root of 2.
Since we have a exponential power here, we're going to first distribute it to the fraction here. So 2 over square root of 2 will now become 4 over 2, because square root of 2 is 4, and the square root of 2, we just cancel the square root here. It will become 4 over 2. Next, remember that 4 over 2, we all know that if we divide 4 into 2, it will now become 2. So multiply 2 by 2, it will now become 4.
And now we can say that 2 secant 45 degrees squared is equal to 4.
So what's up again, guys? And we're back.
I'm Cha.
I'm Doreen.
I'm Angelo.
I'm Maren again.
I'm Justin.
Yeah.
So we're gonna talk about what we have learned in this activity.
So I'm the first one. So I can say that pre-calculus, especially the topic about trigonometry, is not easy for us students that who are not good at mathematics. So therefore, we really need to spend a lot of time studying this lesson. And guys, don't just memorize the formulas, but understand what the topic is. So how about you, Gumba?
I've learned that each identity is connected in a way to each other, especially in simplifying them. We can say that each identity is important. So I learned that
Tangent and cotangent are also equal to sine over cosine and cosine over sine. And that is also important in solving trigonometric equations.
This activity helped me review my knowledge about trigonometry. So this helped me be prepared for this coming examination. So how about you?
I have learned that the reciprocal identities is very important to learn because it would help us to answer or prove trigonometric expressions. And that's all. And this is your Loreto Babies!
You have learned something.